I'm Dr. Viswanathan from the Department of Computer Application, PG, Madanapalle Institute of Technology and Science. Today I'm going to have a topic regarding on image processing using deep learning. Almost every people knows about this concept, and every people are much more intelligent in the base of techniques like you have been learned about artificial intelligence and the subset which you can be able to have like machine learning, deep learning. So more or less today in our human day-to-day our life, many people are replacing about this concept image processing, and image processing are rightly classified is into the categories like digital image processing, medical image processing, and so on and so off. Now more or less I am here to know more about the concept which is based on a medical image processing. Let me go to the concept and let me have the conversation which I'm going to have a discussion. Here, the topic which we have must be learned about here in image processing using deep learning is the leveraging the deep neural networks for advanced image analysis, where it rightly state how we can able to extract the images from a different source of techniques and new models, and more or less from the images only we are going to extract all sorts of information with the help of a neural networks. So that is what the things which we are going to discuss about the leveraging in deep neural networks and more or less the advanced image analysis. So let me go to the concept now. Now let me go with this image processing techniques. This image processing techniques, it rightly encompasses a broad range of methods for manipulating your digital images, where we can able to enhance their quality. Then after that we can able to extract some useful information from the images or from the text also we can able to do it off, and after that we can able to perform some specific task. So these are the things which we rightly knows about in image processing. In this concept, more or less in image processing and deep learning, more or less every people are much more learn about the concept which we can go for classification and for text analysis. In this, let me go for the little discussion which is based on image enhancement. First of all, we can go for context enhancement. This context enhancement, it rightly denotes adjusting the brightness and contrast of an image, where we can able to improve the visibility of features. Right, that is what which we can able to denote in contrast enhancement. Here also we can able to have many algorithms, and we can able to substitute here to notify the brightness and as well as the contrast of an images. Right. Second thing, histogram equalization. It rightly denotes the redistribution of a pixel intensities, where we can able to enhance the image contrast. And third thing, we are just moving for noise reduction. Almost here the filtering techniques, where we can able to have like something a median filtering or else the Gaussian, where we can go for smoothing to remove the noise from images. So these are the right process which we can able to have it in image enhancement. That is what leveraging the process of an images through deep neural network, and as well as we are having some advanced image analysis concept. So these three rightly performs for image enhancement, that is what contrast enhancement, histogram equalization, then noise reductions. Okay, next thing we are going for image restoration. Here we are stating deep blurring. Right, this deep blurring rightly goes for removing the blur which is caused by emotion, the defocus, or some other factors, where we can able to restore the image sharpness. And second thing, we are just moving for image denoising. Okay, image denoising, more or less removing the noise while we are preserving the important image details using some techniques like wavelet denoising, or we can go for non-local means denoising. Almost people where goes with wavelet transform, and there is many thing, and here we are just having like wavelet denoising, or we can just go for non-local means denoising. So this is slightly comes with an image restoration. Second, the third form, we are just moving with image segmentations. Right, almost in image processing we will have some certain process of the procedure where we can able to go for the image processes. Rightly we go for first thing is pre-processing, second thing we are just going for extraction of your images, and rightly goes with future, extraction. Then after that, we are just going for segmentation. So right, after segmentation, we are just going for selection, and finally we are going for classification, and at last we are producing some results. Now in this, one of the main concept here is image segmentation. In this, we are just going to have like thresholding, edge reduction, and finally the clustering. In thresholding, that is dividing an images into regions which is based on your pixel intensities, right? That is rightly holds in thresholding. Then after that, we are moving for edge reduction to identify the boundaries between your different objects or regions in an image. That is also we can able to detect over through some of the algorithms where we can able to have like edge canny or any other. There is a lot of algorithms where we can able to substitute for edge detection. And finally, we are going for clustering. That is grouping of pixels into clusters based on similarity in color, intensity, or texture. So these are the things which we can able to go for in image segmentation. Next thing, we are just going for the process which will take place in the flow of your image analysis is feature extraction. Here also we are much more to have an important concept like corner detection. Then after that, blob. Then after that, texture analysis. In corner, identifying your key points at an image which are invariant while we are going for rotation and in scale changes also. That comes in corner detection. After that, we are going for blob. This blob identifying the region of interest ROI with similar intensity or through some colors which is rightly based on your images. And after that, texture analysis. This is rightly goes for quantifying the patterns and structures in an image where we can able to characterize your texture. So this is comes under where in feature extraction. The most thing we are going for corner direction and we are going for texture analysis also. Meanwhile, we can able to go with blob detection also where we can able to identify the region of interest with similar intensity or colors. Next, the finmost thing, image registrations. More or less, the images you can able to have it in medical images or in digital images or any other. If you are moving with medical images analysis, we can able to have some place of images like MRI, CT, and sometimes nowadays we are having X-ray images also where we can able to extract images and we can able to define your result in an efficient manner where the accuracy value can be easily denoted. So that is what here in image registration. Almost I have specified. For example, if you are using an MRI images, CT images, how we are going for registration. First thing is an alignment. In alignment, matching your corresponding features in multiple images where we can able to align them in partially. Okay. Second thing is wrapping. This wrapping is rightly denotes transferring in an images to correct for geometric distortions or else we can align them with a reference frame. Okay. This is the main thing which we are going for image registration, and this is also considered as the first step for going for your pre-processing of your images and so on. So right, this alignment it right states where we can able to match your corresponding features with in a multiple images and we can able to align them in a spatially views. And second thing is wrapping. Here we can able to go for transforming the images to correct for geometric distortion or aligning them with a reference frame. Okay. Next thing we are going for compression. Right. Here we can able to have a two-way of process. One thing is a lossy, another one thing is a lossless compression. Okay. In lossy compression, we can able to go for reducing your file size of an images. That is by discarding some data, and after that we can able to interpret towards to your human's eyes also. That is comes in lossy compression. Second thing, we are moving for lossless compression. It is also rightly denotes reducing your file size without losing any image data. Right. That is lossless compression, and more or less we can able to go for to preserve our image quality also. So that comes by in lossless compression. So these are the two techniques which is applied in image compression. Okay. Next thing, we are going for morphological processing. So whatever I'm saying here is the fine step which we are going for our image analysis. Now let me state here morphological processing. Here we are having like erosion, dilation, and finally opening and closing of your process. Right. In erosion, it rightly denotes removing the pixels from object boundaries to shrink, or we can able to erode the objects. That comes in erosion. Then after that, dilation, adding a pixels towards to your object boundaries where we can able to expand or we can able to dilate your objects. And finally, we are going for opening and closing. Here, it can able to go for combining your erosion and as well as the dilation operation to remove your noise, or else we can able to fill the gaps in objects. So this comes in morphological processing. And the finest thing which we are going for is in image processing using deep learning. This is one of the fine steps, that is the object detection and recognition. Right. In object detection and recognition, we are going with template matching. That is locating your instance of your template pattern within your images, within an images. That is template matching. Second thing, we are going for feature based methods. That is for detecting your objects based on a distinctive features such as corner or edges. That comes in feature based method. Third thing, one of the fine most technique which we are using here is the deep learning. Here we are stating a convolutional neural network which rightly goes for object detection and as well as for recognition task. Almost you know there is a lot of network which we can take place in deep learning, CNN, RNN, and even DNN also it rightly goes with that. And right now we are just taking here is convolutional neural network for your object detection and as well as for your recognition also. Okay, second thing. Now let me state the importance of having this image processing in various domains. Right. Almost I have prescribed about you that medical imaging or digital imaging or any other source. Here we are just having like a medical imaging, satellite image, computer vision, and so on. Right. Here let me state the image processing. Almost you know it plays a crucial role in various domains. Right. It states the medical image, then after that satellite, then after that computer vision, and many other sources also rightly take place in it off. Now going with this medical images, right, we are just having many radiologists were doing the process of work in this concept, like to take an MRI scan or CT scan and so having some ultrasound images or taking some with x-rays. Now in this process, let me go with this in medical imaging is diagnosis and treatment. Okay, here in this the image processing techniques more or less like almost we have learned like segmentation, feature extraction, and classification also. It really goes for detection and diagnosis of your disease and even the abnormalities from your medical images. That's what like your x-rays, MRI scans, CT, and ultrasound images. Then we are going for surgical planning and guidance which take place in medical imaging, that is advanced image processing where it makes to enable the surgeon to visualize your internal structures, plain surgeries, and we can able to precise using some techniques like image registration and with 3D reconstruction also. Then we are going for monitoring and following up. Here this image processing rightly helps in tracking your disease progression. Then after that we can able to go for assessing your treatment efficacy, and you can able to monitor your patient health over the time through by your longitudinal analysis of your medical images also. Almost while you're going for taking an MRI scan, at the fraction of moment you can able to have at least a 496 images which comes under your pixel of values. That is also makes to be placed in it off. Now you are moving with satellite images and your remote sensing also. Here first thing is environmental monitoring. Here in this image processing techniques, it is rightly used to analyze your satellite images, that is for monitoring your environmental changes, and more or less we can able to include deforestations, then urban sprawl, then land cover classification, and we can go for climate change also. So that is next to be placed in environmental monitoring. It comes for classifications, and we can able to go for segmentation also in this category. Then we are moving with disaster management. This disaster management, more or less, it covers like rapid processing and analysis of your satellite images, where we can able to facilitate your disasters. That is the response efforts, including like disaster mapping, damage assessment, and identifying the areas in the need of relief, or we can able to assistance during your natural disasters like earthquakes, like then floods, and even your wildfires also. We can able to make some classification in disaster management. Okay, and after that we are going for precision agriculture. Here in this image processing, it rightly enables the farmer to monitor the crop health. This crop health also rightly goes for with the help of process. With the help we can go in convolution neural network crop health prediction. That is also we can able to terminate here, where we can able to extract the process, right? Then after that we can go for optimizing your irrigation and fertilization, and we can able to detect some pest and disease which is occurs in the crops, and we can able to do it over through by your remote sensing data from your satellite or from drones also. So these are the things which you can able to have it in satellite image and as well as through by remote sensing. Computer vision. Here, object detection and recognition. More or less, image processing and computer vision techniques are rightly used for what? For detecting, and as well as we can able to recognize the objects in image and as well as in videos. And more or less we can able to enable the application as like facial recognition, even your license plate recognition, object tracking, and some autonomous vehicles also. And we can able to understand their screens also. That is, we can able to help to understand their content and as well as the context of scene by analyzing, and as well as we can able to interpret through by visual data. And the application also like some screen classification, screen segmentation, and visual search also can be able to classified. And finally we are going for augmented reality and virtual reality. That's AR and VR. Here in this image processing, it rightly enables the integration of your virtual objects and information into the real world environment, where you can able to enhance your experience in AR and as well as with virtual reality applications. Right. Now, going with digital photography and multimedia. Almost you knows about the image enhancement, what I have said in before. Here in this digital photography and multimedia, the image enhancement, in this image processing technique is rightly enhance the quality and visual appeal of your digital photograph, like by correcting your exposure. Then after that we can able to go for adjusting your colors, then reducing your noise pattern, and finally we can able to sharpen your images also. Then we are going for image editing. Here in this, the image processing tools like you can able to have image stitching, then panorama creations, and image compositing. It enables the creative manipulation, and as well as we can able to have for editing of your digital images, and it rightly supports some various multimedia applications such as your digital art, graphic design, and some visual effects in movies and as well as in video games. Okay, now let me go for now the concept which we are going here is deep learning. Almost you knows it of. Deep learning is considered to be as a subfield of machine learning, where we can able to focus on developing and as well as we can able to train through by ANN, that is artificial neural network with multiple layers. So that is what we are able to state the term as deep, that is to learn, interact, in the patterns and as well as the representation from your data. Okay, now in this we are going to know about the neural networks. Then after that we are coming for deep neural networks. Almost you know neural network which rightly goes with multiples of neurons, right? These neural networks are considered to be as the computational models, where we can able to inspire by structure and the function of human brain. It rightly consists of interconnected nodes, that is a neuron, okay, organizing into layers. That each neuron, it rightly performs some simple computation on its inputs and passes the results to the neurons in the next layer itself. That comes in neural network. If you're going for deep neural network, these deep neural networks are neural networks which has multiple hidden layers between the input and as well as the output layer. Here, the depth of this neural network, it rightly refers to the number of hidden layers also. Allowing this DNN, we can be able to learn the complex representation of your data. Okay, and after that, we are going for feed-forward neural network, FNN. Right. This FNN are also currently considered as a neural network where the information will flows in one direction, that is from input layer through the hidden layer comes towards to the output layer, and more or less they are commonly used for classification as well as for regression. That comes in FNN. Then after that we are going for back propagation. It is one of the finest most algorithm which we have taken place in machine learning also, but here this is considered to be as a learning algorithm where we can able to use to train your neural networks by adjusting the weights of connection between neurons, where we can able to minimize the difference between actual output and the desired output. And it rightly involves the computing of the gradients of your loss function with respecting towards to your network parameters and updating the parameters using gradient descent or its variants also. Okay. Now, activation functions. Okay, almost you knows we like RELU, PRELU, right? Then extended evaluator linear unit also we have knows it of almost. In this activation function, we can able to introduce non-linearity into neural networks. That is allowing them to learn some complex mapping between input and as well as outputs. Here, some of the common activation function includes here are sigmoid, tanh, then rectify linear units and softmax layer also it makes to be rightly placed in activation function. Almost here we are taking one of the finest algorithm, that is a convolution neural network. This convolution neural networks, it rightly goes for specializing your neural network which is designed for processing your grid structure data, that is image. Okay, and more or less they consist of convolutional layer where they can able to apply their convolutional operation towards to their input data, right? It is rightly followed by the pooling layers where we can able to down the sample towards the feature map and fully connected layers for classification or regression that take place in convolutional neural network. Then recurrent neural networks. These recurrent neural networks are the neural networks designed for processing the sequential data, that is a time series or your natural language also, and they have a recurrent connection that allow the information to persist over the time and making them suitable for the tasks like sequence production, machine translation, and even they can go for your sentiment analysis also, that we can take place for NLP also, right? This comes in recurrent neural network. Autoencoder. This autoencoder also the neural networks which is actually designed for the unsupervised learning, where we can be able to aim to learn some efficient representation of data by compressing and as well as decompressing. Okay, they consist of some encoder network where they can be able to compress the input data into a lower dimensional representation, and the decoder network can be able to reconstruct your original input from your compressed representation also. Okay, in this we are just going for GANs, that is generative adversarial networks. Okay, this GAN, it is rightly a type of a neural network architecture where it consists of two networks. One thing is a generator, and after that a discriminator, and they are trained simultaneously in a game theoretic framework. These GANs, it rightly used to generate their realistic synthetic data samples like images or audio by learning from real data samples also. So these are the fine move which I like to have some prescription over in image processing using deep learning. And finally, thank you for having some patient listens towards to my slides. Thank you so much.